Getting the budget to pay for security controls and put them in place to protect assets can be difficult. We need to make sure that we acquire support from management to get that budget, but we also need to make sure that it's worth doing. There's no sense spending $5,000 a year to protect an asset that is worth much less than that. And that's where quantitative risk assessment comes in. What we're really talking about is a risk assessment that's based on numeric values, often dollar amounts, but it doesn't have to necessarily be dollar amounts. But that's going to be what we focus on here. So in order to determine, is it worth putting this security control in place, because it costs money, to protect an asset? Well, to figure that out, we have to know a few things. First of all, what is the asset and what is its value? The asset value, or the AV, is going to be important. We might have a customer database that is valued at being worth $50,000. That's important to know in order to properly calculate a quantitative risk assessment. Now, we also have to consider the exposure factor, or the EF. What's that? The exposure factor is the amount of that asset that is considered lost when a negative incident occurs. So we have the asset value, usually a dollar amount, of course, and we have the exposure factor, which is expressed as a percentage. For example, if we have an exposure factor of 1, which equates to 100%, that means a single negative incident results in a complete and total loss of that asset. So we need to be able to put these things together to calculate what's called the single loss expectancy, or the SLE, the SLE. Now, the single loss expectancy, as the term implies, how much loss do we experience during one negative incident? So in order to calculate the single loss expectancy, we multiply the asset value by the exposure factor. Now, for the Security Plus exam, make sure you understand how to derive some of these numbers. So calculating the SLE, the single loss expectancy, asset value multiplied by the exposure factor. So for example, let's say we have an asset whose value is $24,000. If we have an exposure factor, or EF, let's say of 12.5%, that's how much loss we might expect from a single negative incident. If we multiply $24,000 by 12.5%, we get $3,000. What is that again? That's the single loss expectancy. When we have one negative occurrence, we're looking at a loss of about $3,000. Now that's important because we then can use that to calculate other items that are going to be very important in your quantitative risk assessment. Let's do a full example. So we've got, let's say, a website, an e-commerce website that generates $24,000 of revenue per day. That's the value of that asset on a daily basis. So the asset value on a daily basis is $24,000 in our example. Assume that we've got a risk of downtime, whether due to a malicious attack or to some kind of failed hardware component. And from past experiences, we have learned that on average, when our e-commerce website goes down, on average it's down for about 3 hours. So if we take 3 hours and divide it by 24 hours within a day, we get 12.5 as a percentage. That's our exposure factor. So we know our asset value, we know our exposure factor. So we know that we calculate that single loss expectancy by multiplying the two together. 24,000 by 12.5, and we said that that would be $3,000 that would result as a cost of 3 hours of downtime for that e-commerce site. And then we take it a step further by learning how to calculate the annual rate of occurrence, or the ARO. So this is the expected number of yearly occurrences, in our example, downtime for our e-commerce website over the span of a year. So what we can then do is say, well, due to past knowledge, we have experience that suggests that that might happen 2 or 3 times a year, as an example. So when we calculate the annualized loss expectancy, we've already calculated the single loss expectancy, right? That's one negative occurrence. Well, all we have to do is determine what does that cost over a year if we have multiple occurrences. So the annualized loss expectancy is the yearly cost of bad things happening, and we determine it by multiplying the single loss expectancy, which we've discussed, by the annual rate of occurrences. How many times is that going to happen per year on average based on historical knowledge? So this would be another one of those items that you're going to need to know how to calculate on the exam. Not only the single loss expectancy, but what we're talking about now, the annualized loss expectancy. So for example, we already know that in our example of our e-commerce website, a single negative incident of 3 hours of downtime is going to cost us about $3,000. That's one incident. Well, let's say that our ARO, annual rate of occurrence, is 2. We expect that will happen twice per year. Well, that means if we multiply the single loss expectancy of 3,000 by 2, we get 6,000. Now, why is this all important? Let's kind of bring it all together. We are calculating the annual loss expectancy, the ALE, because we want to compare that against how much we're spending annually for security controls to protect against that threat being realized, against our e-commerce website. And what we could then say plausibly is that, okay, our annualized loss expectancy for that asset is $6,000, so it would make sense to spend $6,000 or less to protect that asset. Spending more does not make sense. So this gives us a sense of why we even bother with a quantitative risk assessment.